So we will have a look at the first exercises and their solutions. So both exercises are about factors and how they influence the plots that we do in ggplot. So in the first exercise 1.1, we recreate the plot of the iris dataset that we saw on the slides. So I will just run the code here. As you can see, it's a scatter plot colored by species. On the x-axis, we have the sepal length, and on the y-axis, the sepal width. And we use the theme BW to have a light background instead of a gray background. The species column is automatically converted to a factor in ggplot, and it uses the alphabetical order. So Setosa, Vesiculo, Virginica, it's the alphabetical order. And in this alphabetical order, the default colors of ggplot are assigned to the species. And now we want to reorder this factor level to Virginica, Setosa, Vesicular, create a plot again and see what happens. First, make a copy of the iris dataset called iris2. We can have a look here. And you see that the species is a factor. And we can see here that we have here the levels Setosa, Vesicular, Virginica automatically in the alphabetical order. And there are also multiple ways to do it, but here we want to use the forcats package. It's part of the tidyverse. And use the factor relevel function on actually this column here. And then specify the order we want to have Virginica, Setosa, Vesicular. I will do this. And you see that it changes here. And if we look at the factor again, you see that it now has the desired order Virginica, Setosa, Vesicular. If we now do basically the same plot again, you will see that the order in the legend changes, and by that also the assignment to the color changes. So before here, for example, Setosa was red as the first element here. Now it's green because it's the second element. So in the exercise 1.2, we again have factors, but we are looking at the Gapminder dataset. We can use the package Gapminder for that. And we will have a look at the help page of this. So we can load the package and then write question mark Gapminder. And then you see an actual explanation of the columns we have here. We want to use this dataset to construct a simple scatter plot that plots the life expectancy against the log10 transform GDP per capita and color it by continent. And then we want to change something about the labels of the factors. They have a continent called Americas. We want to rename it to South and North America, and it has a continent called Oceania, which we want to rename to Oceania and Australia. And we also have an advanced part of the exercise where we add a factor level Antarctica, for which we of course don't have any data. But here the question was to search a bit around on the internet how you can actually make ggplot to show this empty factor level in the legend. So we will have a look at that. So we load the tidyverse and the Gapminder package. We have here data Gapminder. If you click then here on the environment, you will see that the dataset is loaded. So we have 6 variables: country, continent, year, life expectancy, population, and GDP per capita. And we have 1,704 observations. Then we recreate the plot that was asked for. So we have here the log 10 of the GDP per capita on the x-axis and life expectancy on the y-axis, and continent is color. So we can run it, and we see that we received this plot here. Like before, we save a copy of the Gapminder dataset, Gapminder 2, and we see that the continent is a factor with 5 levels. We have Africa, Americas, Asia, Europe, and Oceania. And we want to rename it. So we use the factor function and define the labels. So for example, Africa stays the same. Then Americas is renamed to South and North America. Asia and Europe stay the same. And Oceania is changed to Oceania and Australia. We do this. We can look at the continent column of the Gapminder 2 dataset, and we will see that we have now renamed Americas to South and North America and Oceania to Oceania and Australia in this case. So we plot this graphic again, and you see that it doesn't really change something about the plot, but only changes here the labels in the legend, and they need a bit more space because they are longer. So we have a bit less space for the plot, otherwise it does not change anything. So now we were asked to add Antarctica as a level. I make a third copy, and for this I'm now adding Antarctica here. So, and you can see also, yeah, look at Gapminder 3. You will see that Antarctica here is now part of the levels. It now also has 6 levels instead of 5. If you want to make a table of it, so Gapminder 3 dollar continent, you will see that it pops up here with 0 entry. So this is a so-called empty factor level. Maybe I just remove this line here first. So if you would recreate the plot as normal, then this would show up and it doesn't change anything to before. But what we can do is to use the scale color discrete function and have the option drop false. And then this will actually prevent dropping this empty factor level. So we create the plot here and see that we have Antarctica here with a separate color. So this means also all the other colors change a bit because this default color scheme uses like a certain palette that changes depending on how many levels you have. Here's also the show legend true I added, because this will actually force here this dot for the Antarctica, so I can maybe remove it. And you will see that there is no dot here for Antarctica for some reason. So you have to have this show legend true activated so that it's also showing dots for the empty factor levels.